back with another challenging problem on integral calculus, how to evaluate the integral of this function, which is in the square root. So guys, this is also thought of as a nested square roots problem, and we want to evaluate the integral of this function. Again, you can see that there's no direct ways of evaluating something like integral of some function which looks like this. So guys, what we are going to do is we're just going to take up this function, and then we are going to try and see if we can simplify this or transform this or do something with it so that we are able to evaluate the integral. And guys, this also qualifies for a challenging problem, right? So what I'm going to do is, guys, in step one, what I'm going to do is I'm going to say let y equals to this whole thing right here in the radical. So let's say y equals to this x plus, and then, you know, this x, it just keeps on going. It's just repeating, right? It just keeps on going forever, right? It is like, it's called also infinite nested problem, right? Infinite square roots. So it just keeps on going forever. So here's the thing that one has to like notice, or one has to like look at this and carefully realize that, guys, this y can also be written as, now this is the most critical step for this problem. Guys, this x and then plus, I'm going to write this, and there's a reason why I'm writing it in a different colors, and you will see that in my next step. So I'm just rewriting this, but I'm using like two different colors, and you will see why I'm using these in the next step. So from here, you can see now that this y equals to square root of x plus. But guys, this in the blue color isn't the same as this y that we started with. Why? Because for one reason, that this goes on forever, so it does not really matter if we are ignoring one of the x's here. It's like, because it is just going on forever and ever and ever. It's going all the way up to infinity. So if I even take out infinity from infinity, what am I left with? I'm still left with that infinity, right? So in this case, this is still going to be x plus y, right? Guys, this is kind of a crazy concept, but that is the idea that one has to use here, the idea of infinity, and the idea that if one takes away even infinity from an infinity, it's not like we're going to be left with nothing. We're still going to be left with infinity, because infinity is not just any defined number. It is something that we cannot really count, right? So taking away a small quantity from an infinity is not going to change the infinity. It is still going to be huge and humongous, right? It's like, I mean, I'm sure you guys already understand this basic concept. It's like, let's say you have like $1 trillion or even more than that, and you're taking away $2 or $10 from that. It's not going to like it's not going to make like any difference, right? Similarly, now here we're talking about like not just trillions and billions, we're talking about infinity, like which we cannot really count, and we're taking away something from there. It is not going to change the infinity. It's still going to be a big, huge number, okay? So guys, now let us focus on this particular equation right here. There was no direct way of evaluating this, guys, so one had to like kind of just analyze this, and from this analysis finally we got to this point. So guys, keep in mind, this is evaluating the integral of, now this is same as evaluating the integral of this y now, right? Because we said let y be this expression right here. So if we can integrate y, we basically have the answer for the integral of this particular function. Now to do that, guys, all we need to focus on is this particular equation. And this is a radical equation which we can do something with it to simplify things. I'm sure you can, like, obviously looking at this radical equation, the very first thing that we like to do when we have to work with radical equations is like, we want to get rid of the radicals. How do you get rid of the radicals? You just square both sides. And guys, that's what we are going to do here. So I'm going to square both sides, and let us see what we get. If I square these both sides, I get y squared equals to x plus y, right? Because the radical will just go away. Guys, now what we are going to do is, we are going to try to bring everything to the left hand side and make it look like a quadratic form. And it is a quadratic form if you think in terms of y squared, right, as a standard form. So just looking at this equation, looks like a quadratic form. Why don't we go ahead and try to solve a quadratic form in like for y, right? So how can we solve this quadratic form in terms of y? Like how can we find the value for y? Guys, there's few different methods of doing it. One of the methods is by using the completing the squares method. I'm not such a big fan of that completing the squares method. That does not mean it is not important. It is a very important concept, and one should know how to use completing the squares. Guys, the other method would be to use just the old quadratic, like the simple old quadratic formula. And guys, I like to use the quadratic formula, and that's what we're going to use here. And then we're going to try to solve for the y, okay? Because if we get y, if we get an expression for y, we already have this as an expression for y, but we cannot do really anything with it. So we are trying to find or evaluate or get another expression for y, which might be simpler or for us to actually evaluate the integral. So if I cannot find the integral of this particular mess, I'm trying to transform that into something simpler that we can find the integral for. And if we do find the integral for that guy, then automatically we have the integral for this particular function as well, okay? So let's use the quadratic formula, guys. Using the quadratic formula, we know in this case y is going to be, we're solving for y, is negative b plus minus radical b square minus 4ac. I'm just rewriting the quadratic formula. I'm sure you already remember this. If not, just please go back and review that. So guys, negative b, keep in mind there's a negative 1 here, so it's negative times negative 1 plus minus b squared is negative 1 squared minus 4 times a. The coefficient here is 1, and guys, be careful. Here the coefficient, we don't actually, there's no, we have to treat this as a constant because we're solving in terms of y. So we have to treat that negative x as a constant. So my c is actually negative x, okay? So don't let that trick you, like there's not a constant there, but x or negative x is going to be treated as a constant here. And then you got to divide this by 2 times a, well, coefficient of y squared is 1, so 2 times 1. So when I simplify this, negative times negative is positive, and I'm just quickly going to simplify the piece inside the radical. And guys, I expect you to actually be able to do that on your own as well, and then divide it by 2. Guys, this is my expression for the y, and you can clearly compare this guy with this whole infinitely square rooted nested mess, and obviously we can see that this is much simpler than this whole thing. So, but at the same time, we understand that this and this guy, they are equivalent because this is y and that is y as well, because we started by substituting or letting that to be y. So guys, now let us work with this y and look at this y, break it down, analyze this, and see if we can actually evaluate the integral for this y. If we do, then that would be the integral for this whole function. Guys, these problems, I find them really interesting and fun, so I hope you would find them fun as well. Of course, they challenge you, and I think one of the goals of doing mathematics is that that we should be challenged sometimes, okay? So guys, we're going to write this as y equals to 1. I'm going to break it down as 1/2 and plus minus square root of, I'm going to rewrite this as 4x plus 1 for no special reason, I mean, but so that like when we actually go to the next step, maybe it will be easier for us to see how to write the integral for that. Guys, here before we move on, we have to be a little careful. Guys, this is a square root function, right? Everything is in the square root. There's this big square root and there's a lot of other square roots. Guys, there's something that one already knows, or we already know about the square root functions, that the square root functions cannot be negatives, right? Because if we are doing everything in the real number system, then the square root is always going to be either positive or it can be 0, depending on if all the values, like if the x values are 0. So there's something we know about this function, the nature of this function, that it is always going to be greater than or equal to 0. Well, let us not worry about equal to 0, because that means x is all 0, then it won't be, the problem would not really exist, or it won't be exciting. So let's say that of course it's going to be less greater than 0. So guys, if we know that this whole thing is going to be greater than 0, that's right, because we know from the basic understanding that the square root function is always greater than, is always positive, right? Guys, that means that we have to get rid of this negative sign. We cannot have a negative sign, and if you want to see why that is the case, because guys, if I leave that negative sign right here, and let us say when I simplify this guy for any bigger value for x, and I get a negative number here, then I get a bigger number here, then I have a negative in front of that, and then there's a smaller number like 1/2, so I will end up getting a negative value for y. But we already know that the radical function cannot be negative, right? So that is the reason we have to ignore the -1, we just have to take the positive one. This is just positive, okay? So guys, I hope you understand why we are ignoring the negative. Although a quadratic equation has always 2 roots, but here in this case we have to ignore the negative one and we just take the positive one, because we understand that the radical function is always supposed to be positive, right? So let us look at this now, and if we are able to evaluate the integral for this, that automatically means we got the integral for this, because this is y and this is y as well. So let us go ahead and try to evaluate the integral for this guy. Of course, we know it's with respect to dx. We can break it down as integral 1/2 of dx. Guys, I'm going to break it down into two pieces, and this, guys, 1/2, I can already take it outside. And this 4x plus 1 with the radical, how about if I rewrite this as 4x plus 1 raised to the power 1/2? And the reason why I am writing it or rewriting it as 1 to the power 1/2, because we know that we have a power rule which looks like of the form x to the power n, right? So then we will be able to use the power rule on this guy. Guys, this is pretty simple, 1/2 and just x, because integral of a constant with respect to dx is just x here, especially because there's only 1, this is 1/2. And this guy, guys, we have to treat it like and we are allowed to treat it like a power rule, because this is a linear function. As long as this is linear, we can use the power rule here. There's only one extra step that one has to do, and I have been like trying to do this all the time with different examples. So guys, n plus 1, 1/2 plus 1 is what? 3/2. Got to divide by 3/2 as well. But don't forget, you also have to divide this guy by the derivative of the inner, and in this case, the derivative of the inner is just simply what? Positive 4. Okay. Don't forget there's a plus. Of course, there's a plus c at the end. Guys, we're almost done, but I think we need to like a little bit simplify this piece right here, and then we should be able to get the final answer. And that final answer would be the integral for this given square root function, right? So let us go ahead and try to simplify this. So guys, I'm going to simplify this right here, and then I will bring it back. So it's 1/2, and then I have 4x plus 1 raised to the power 3/2 divided by, well, 4 times 3 is 12, and this 2, guys, it just goes upstairs, right? We know that what happens when you have this fraction and you take it like this goes upstairs and this 3 stays down here. From here, what happens, guys? This 2 and this 2 crosses out. Now, that's not the only way to do it. Guys, you can also think about, like, you can simplify it right here. This 4 times 3/2. 4 can be divided completely by 2. So I'll get a 2 here. So 2 times 3 is 6. 6 times 2 is 12. So whether you use this method of flipping this or you just simplify it right here and then multiply, guys, you are still going to get that 12 in the denominator. So what does that mean? That means I can get rid of all this. I can simply put an 1 over 12 here, and that's it, guys. That's it. We have the integral for this square root of a nested x function, but again, directly we would not be able to do it, so we have to just analyze or look at this radical thing carefully. We said let it be y. We understand the idea of infinity here, and then we square it, we work with y, try to solve y. And what we found was like, what we got was something much simpler than this whole mess. And then we were able to evaluate the integral for that. Guys, there's so many other interesting and fun problems in integration. So if you find them interesting and fun and you decide to find more or explore more, I would encourage you to do more of these types. Guys, again, keep trying them. If you need any help or hints or you want to share them with me, please feel free to share those with me, because I find them fun and interesting myself, and they kind of challenge me as well. So guys, keep working. I will see you next time with another video.